Okay, in this video, I'm just going to quickly review the three formulas on calculating the probabilities of intersections, unions, and complements using formulas. So I'm not going to show you any tree diagrams or area models today, no Venn diagrams, nothing like that, just formulas. So an intersection is when we have and, so we're looking at two events occurring together and we have two outcomes that are happening together. So when you're asking for the probability of A and B, you're going to multiply their probabilities together. So you have to know the probabilities, okay? A union, oh, and by the way, when you multiply probabilities, you either have to have fractions or decimals. If you're given the probabilities as percents, you have to convert them to either decimals or fractions, okay? And sometimes the problem will tell you how they want you to do it. If it's a union, it's got this or, so you don't care if you got outcome A or B, it could be one or the other, because maybe you win under either condition. And so that you're going to calculate by adding the probabilities together, but then you have to subtract the probability of them both occurring, the overlap of them both happening. Why we subtract, I'm not going to get into right here, but you do have to subtract that. So that means you have the probability of A plus the probability of B, and we just saw that this probability, this is an intersection, we get by multiplying them together. So then you will subtract the product. So add and subtract the product. Now, if two events cannot occur together, if they are mutually exclusive, for example, you cannot be on, let me get this thing out of the way here. You cannot be on Honor Society and have an F in a class at the same time. They are mutually exclusive. There might be some schools where you're not allowed to play two sports that are happening during the same season. They would be mutually exclusive. So if you have mutually exclusive events, that means that the intersection of them happening together, the product, would be 0. So sometimes you have to think about the situation and ask, even though they're giving me the probability of A and the probability of B, I have these numbers, I could multiply them, but you have to ask yourself, could these two things actually happen together? And if the answer is no, then you'd have to use 0 for that intersection. Okay, so that's how you calculate a union and an intersection. The last one we're going to look at is a complement. This is the probability of something not happening. And so the easiest way to do that is to take 100% minus the probability that it did happen. Okay? Sometimes the notation you'll see for not A would be A apostrophe, like that. If you're using a decimal or a fraction, you'd use the number 1 and then subtract the probability of something actually happening. For example, if the probability of it raining is 2%, then the probability of it not raining is 1 minus 2%, or 98%. They are complementing each other together. They add up to a number we care about, which is 1. Okay? So let's look at an example using these formulas here. At IHOP, the probability of buying coffee is 82%, and the probability of buying pancakes is 73%. I completely made up those numbers, so don't get mad at me if it's not real. What is the probability of getting a customer getting both coffee and pancakes? So what we're going to do is multiply 0.82 times 0.73. You would use a calculator and you should get approximately 60% when you multiply those. 0.6 or 60%. Okay. By the way, as a, if you wanted to convert this into a fraction, this would be 60 over 100, or 6 over 10, or divide top and bottom by 2, 3/5. So for my class, either write your answer as a decimal, a percent, or a reduced fraction. What is the probability of getting coffee or pancakes? So for coffee or pancakes, we are going to add the probability, so 0.82 plus 0.73, but we have to subtract the product of them both happening. So we'd have to multiply 0.83 times 0.73, but we already did that up here. So this is just going to be I'm just going to erase it. 82 plus 0.73, which would give you more than 100%. If that ever happens, that means you did something wrong. So then you have to subtract the overlap, which is the product of the two, which was 0.6. And when we do that, you should get, I think, not approximately, but I think you should get exactly 95%. Again, you could write this as a percentage, or you could put this over 100. And that can also be simplified. Divide top and bottom by 5. I don't want to do that right now, but pretend we did. Okay, the probability of not getting coffee or pancakes. So this event, coffee or pancakes, we just calculated it up there. So I want to know the probability opposite it, the complement. So we're going to do 1 minus the answer we got over here, 0.95. Or 100% take away 95. And you should get 5%. As a fraction, that would be 5 over 100. And that could also be reduced, but we're not going to do that here, okay? So that is how you use formulas to calculate an intersection and a union, that's an or, and a complement, which is not.